Hi everyone. Welcome at my presentation about experiment-driven software development, or as I said in the program, why you should be running experiments in your backend to build the best application. My name is Hiltsje Smilde, and I work as solutions architect at a company called Optimizely. We build software for running experiments, both in the front end and in the back end, and I work as solutions architect at various companies implementing that software. Before this, I worked as software developer at Capgemini, and before that, I was actually a researcher. And by now being in the field of experimentation, but also working for a software company, I'm able to combine my knowledge from software development with my knowledge in my research background, and in this way, I hope to introduce you to the field of experimentation in software development. So, what do these three companies have in common? Besides that, they're all like super successful. They all have great methods to measure what their users are doing. And in that way, they set up their software development. It means, for example, that Facebook usually rolls out new features first in New Zealand to see how the people in New Zealand respond to changes before they roll out anything to the rest of the world. I don't know why they picked New Zealand, but it's apparently a popular location to test your new features. Netflix tests, for example, different algorithms of trying to advise you on which new series you should be watching. And Spotify can roll out different new functionalities to, for example, 10% of users to see if people like that new functionality. Jeff Bezos from Amazon even says that the success of his company is directly tied to the number of experiments they run every year, every month, every week, and every day. So clearly, experimentation is something that's super important for the companies in this world that are the most successful companies. So what should you be doing with it? And what is this exactly, this experimentation? So that's what we're going to be talking about today. So the first thing, experimentation is often referred to as A/B testing. So I sometimes use the terms interchangeably, although I like the word experimentation much more, because A/B testing implies that it's just a small thing, while experimentation is so much bigger. We're going to talk about exactly what is A/B testing and why should you be using it. After that, we'll look into how software development has changed over the years, and why it's now important to do experimentation as opposed to maybe 10 years ago. And we'll look at the software development lifecycle. How can you be using this new technology in the whole software development lifecycle so you are developing the best applications? So, first thing, A/B testing or experimentation, and why you're going to do it. So, A/B testing is often referred to a simple thing like this. We have our web app, it has a button, it's black. Someone proposes, it should be red. We measure what people do. We give this 50% of the room the black button, we give the other 50% of the room the red button. We see who buys more derby tire backpacks, and then we decide which button color is best for our website. But this is obviously just a simple front-end change. And you're all being back-end developers. I heard the survey during the keynote today. No one identifies here as a pure front-end developer. So these are not the changes we are looking into. Another example. This is a company called Beta Brand, and they wanted to sell people this shirt. And someone at that company proposed, what would be the best way of selling this shirt? How should this model look like in order to sell this shirt as many times as possible? And they did an experiment on the beard of the guy. So in one variation, the guy had a small beard, or actually almost no beard. Then they created 6 photoshopped images of the same guy, from no beard to caveman. And then, so they created the whole audience in 6 groups, showed different pictures, and saw how many people would buy this perfectly nice shirt. Well, they measured. They even looked at the difference if male and female were influenced different by the looks of this guy. But it was concluded that for both males and females, this shirt sold better if it was worn by a caveman than when it was worn by a guy without beard. Now, what does this tell us about web development? Absolutely nothing, because we're not going to put randomly beards on people like on every single image of your website, just to try to sell more shirts or to make the website more usable. So this is not really the most efficient of example of A/B testing, but it's a really funny one, so that's why I wanted to share it here, of course. So at the company I work at, we have software for doing this. And we actually checked how people are writing these different variations. So here it's really easy. All of these changes are a simple image swap, so it would be just one line of code. But of course, there's way more complex things that we can change. We can add different algorithms for performance and test them against each other or something like that. So we looked at data of all of our customers and how they make these variations. And not necessarily what that variation is, but we looked at how many lines of code they wrote to make such a variation. So not just an image swap, but any other variation. Of course, an image swap would just be one line of code, but we counted that for variation code of anything our customers would be doing. And we didn't look at what they would be changing, we just looked at how many lines of code they would write to make a change, and using that as a metric for how complex the change was. Assuming that changing the color of a button, changing an image, or making any simple front-end change would maybe be 1 to 5 lines of code. Now, I'm not encouraging that everyone should be writing massive amounts of code, and when you measure 200 lines of code, it might be someone who doesn't know how to write a for loop. But in general, we can say that the more lines of code someone is writing, the more complex a variation is. So we count here 24 lines of code, and we group that into different categories. And then we looked of all the variation code written by our customers, what does that look like? So actually 51% of experiments only use 1 to 5 lines of code. That means that 51% of all our experiments that are run by our customers are actually very simple changes. So the button change, the image change, and those kind of things. And only a very small percentage actually has a lot of changes that actually are significant changes. And then we looked at how often is such an experiment successful. We have a statistical engine that automatically calculates if a variation is statistically significantly different from the other one. So it would look for all those conversion rates of the bearded guy, if it's actually statistically significant if you put a big beard on the guy to sell that shirt. And we see a certain percentage has a significant uplift, a certain percentage has a significant going down, which means that it was actually, you thought you're making an improvement, but you're actually not improving it. And there's actually a lot of experiments that give you inconclusive results. But if we look at this in a relative way, we see that when you write more lines of code, you have twice as much chance that you're actually creating a winning variation. So it means that more complex variations actually have a way higher rate of success. And that's why we say developers should be doing experimentation, because to create these complex variations that require actually writing of code and not just a simple change, we have a much higher rate of actually influencing user behavior, how the app is used, and all those kinds of things. So there's two things we should be doing when we look at complex experiment. The first thing is let developers do the experiments, because if they're more complex, you have a higher chance of finding a significant improvement. Another thing we could be doing to make it more complex is run experiments on the server side, instead of running experiments just in the front end, which has a huge impact on the users as well. There's a lot of examples of what you could be doing on the server side with experimentation. One of them is feature management. It means that you create a feature and roll it out in different stages or different ways, and in that way learn about your customers. The same way Facebook and Netflix and Spotify are doing that. You could look into performance optimization by creating different algorithms in your backend for how your website is loading, or saying, oh, this I need to load sync, but I would prefer to load it async, and test those different variations towards each other and see if it actually makes an impact on the user of your application. Another thing you could be testing is, for example, algorithms. We'll look into an example of that. You can roll whole website redesigns. So a lot of companies have a website for multiple years, and they also have customers that are using that application for multiple years. And then they're like, oh, it looks a little bit old-fashioned. I'm going to do this cool redesign, hire a UXer, and make it look like super fancy. And then all their users start complaining because no one knows where to find anything anymore. To prevent that, you can do that by experimentation to actually figure out what your users want and redesign it only in a way that it's still really usable for the people using your application. So it actually mitigates the risk of doing a relaunch. Yeah, you can test the user experience. With running things on the server side, you can also run experiments on pricing. So let's say you're an e-commerce website and you want to know how much discount you should be giving before people are incentivized to buy something. Then you could give different percentages of discount to different groups of people and figure that out. That's just one example. Airlines are very notorious for using this. Yeah, they, for example, have even different pricing if you look for something on a different day of the week. Then the other thing that's cool with server-side testing is that you cannot only use it in web applications, you can also use it in other things like chatbots or voice. Currently, if you talk to an Amazon Echo, it's all quite basic. What if you could program Alexa in a way that it gives different responses and then also checks how people interact with her? And in that way, you can improve the way you interact with either a chatbot or a voice system. One example of a different algorithm for search is this website. It used to kind of, in a certain way, order the hotels when you looked for one. And then someone developed a different algorithm, and it was based on the search keyword people used. So the hypothesis was, this is going to be more relevant to our users. And they proved by changing the algorithm and changing the way that hotels were listed on the website, that they had 24% higher click-to-sale, a 30% higher add-to-cart rate, and an overall 210% added conversion rate. So this experiment, by running that on the server side, testing a different algorithm of how your website should look like, really matters also to business users, for example. So that's why I say it's important. Developers should be running experiments because complex experiments create more significant uplifts. And by running experiments on the server side, we can create much more complex experiments that are giving you better results. So let's look into change. How software development has changed and why that is important to what we're doing today. So who still remembers this? Yeah, so we all know still kind of that it used to be like this in the days. There would be developers sitting in Microsoft's building, and they would design something. They're like, Windows 95, that sounds cool, it's 92, we have probably 3 years to make it. We build it, we launch it infrequently, especially with this kind of CDs. Like, you can't just launch to the web like you do today, but you have to launch it on a physical device that you then sell to people that they have to pick up in a physical store. You almost can't imagine it anymore. And obviously, you don't have any real-time customer feedback, because by the time it arrives at the customer, the developer has been done probably for a year, because the testing happened after the development. So you have absolutely no clue what your users actually want. And that's why we say launch and pray. I think 95 was received quite well. Vista was a bit less. But currently, we hear all these things in the news, like Instagram Stories is a new feature rollout. Roll out this, small percentage of users, tweak apps in key markets. What is this new way of developing? Well, it's design, build, experiment, and then iterate. And instead of launching and praying, we are experimenting and iterating until we know that the product we're developing is actually what our customers want. And we're testing that in a live environment, so we actually get real-time customer feedback. And it's also nice for you as developer, because you're actually sure that the code you're writing is actually used by someone. And you're not writing code that then a year later is said like, oh no, we don't need this anymore. And then you spend all this time creating something that no one's ever going to use. So it's much more fun to actually create stuff that you know people ask for. So the lessons learned from the best-in-class companies. The best-in-class companies release all the time, they measure everything, and they iterate rapidly. And what does this mean for our software development? Well, of course, we're all familiar with this, the waterfall way of developing software, which is what we shouldn't be doing anymore. Then, everyone is also familiar with this, the agile way of software development. And this solves a few issues. It solves mainly that we have to release more often, and also that we have to iterate on what we're doing. But the agile method doesn't necessarily describe a way of how you're actually getting feedback. And a lot of times what I see happening in companies is that a product owner has a backlog, and instead of being able to change that product backlog, that backlog is often predefined for quite some time already, and in that way it becomes actually really hard to do an iteration and to add other things to your product backlog that might have changed priority. So that's why I say we should be doing experiment-driven software development. And it means we don't have a predefined backlog. Of course, you can still have a vision of where you're trying to go, but you actually learn from your users, and based on that, decide what is the next feature I should be developing, to who should I be rolling this out, would this feature maybe only be interesting for people using a mobile app and not for people on the desktop, would this be only interesting for people using my API, anything is possible. And there's another issue, well, actually another example that I have about why it's so important to run this experiment. Because with Agile, you put things on the product roadmap that you think your users want. But there's many cases that we actually don't know what our users want, and we make assumptions. And we have some data on that as well. We call that the problem with A/B testing. So when we do an A/B test, we only have 2 variations. But why wouldn't you be running an ABCDEF test? Like the first example with the beard man, which had like 6 different gradations of beard. And when you force yourself to make multiple variations, you're also forcing yourself to get more creative. Because it's really easy to find one solution for a problem and not experiment at all and just deploy that to your users. But it's way more hard to find 5 of the same similar solutions to the same problem. So we looked again at data of all of our customers, and we see actually 77% of current experimentations run by our customers are actual A/B tests, just A/B. There's an original and there's one variation. I'm just going to see if my variation is better. But we would be learning much more if we immediately tested a few other ones. Obviously, you need to have a decent amount of traffic to be able to split it up a certain way. So at some point, there's going to be, like, you shouldn't be adding 20 variations, because then you're adding too much, and you split up your traffic so much that you won't be able to get any statistical significant results anymore. So for this again, we looked at how much significant uplift there is, how many significant reduction experiments there are. So you had the wrong assumption, you were trying to uplift something, but there was actually not a good idea. Let's imagine you had launched that without measuring it. That would have been a bad idea. And of course, there's also still experiments that are inconclusive. If we make this relative again, then we see again that by adding 5 or more variations, you can increase the win rate by 75%. And you see that it goes slightly down again with more than 6, but that's maybe because at some point you're making your traffic buckets too small. And we actually threw these results into our own statistical engine and figured out it was actually a significant difference. So by adding more variations to an experiment, you're actually experimenting more, because you are being more creative by making up different ways of doing this. And that's helping you to actually reach the results you want. Because if you're just launching one thing or just testing 2 different variations, you don't have a high chance of finding what your customers actually need. So, That's why we say everyone should be doing experiment-driven software development, where what you do is based on actual data that's preferably tested statistically, so you know that there is an actual change, and it doesn't just looks like a change. And in that way, we are capable of putting this into our software development lifecycle. So how are we going to do that? Because there's many stages in your software development lifecycle that we want to maybe experiment on. So we have a discover and design phase. We have a phase in which we're building and experimenting, and eventually we roll that out. And of course, once we have a new feature, we still want to be experimenting on it. Because even if we tested 5 versions of the feature and we found the best one, there might be still other ways to improve that new feature. So how can experiments help you to prioritize your roadmap? Well, you might have to go back to the front-end developers for a bit, because you can do what we call a painted door test. It means that instead of developing the whole feature, including a backend, a server, a database, whatever, everything that takes a lot of work, you create the notion of that feature existing in the front end. Now, you do have to be careful with that sometimes, but it gives you a really great idea of how many people would actually like to have that feature. Something we tested on our own website, in our portal that our customers are using to do experimentation on their website, we are actually running experiments ourselves as well. So we test how people use our software. We created these 2 extra boxes. We have a machine learning team in San Francisco, and they were thinking, wouldn't it be cool if we develop a machine learning algorithm that tells us how people are grouped together, or what is an audience on our website? Of course, developing such an algorithm takes us quite a lot of work, time, money. So we want to first know if our customers would be interested in using this feature. And we tested various ways of promoting the feature. We called it automated personalization and said it was in alpha. Or we called it machine learning and said try it. And when people would click on this button, they would get this box. We're exploring developing this feature. And if you were interested in this and you would like to sign up for our alpha users, then you can do here. In this way, we are getting customers that want to use this feature and help us develop it, because they can be in a group that tells us what they actually need. And we actually know that there is a significant amount of our customers actually interested in this feature, and that's why we tell our machine learning team, you should be developing this. And that's something that's currently happening. Another example is from one of our customers, The Guardian. They had a save for later functionality in their mobile application, and they wanted to know if people would also like to use that when they were in the web application. So this is what it looked like on mobile. And option 1 would be to build the save for later functionality on web, meaning parity between platforms, right? Kind of makes sense to just go and develop that. Option 2 is to do such a painted door test, and then measure demand with just an icon without any functionality behind it. So they actually added something here. And then when you click the button, they said Save for Later isn't available yet on our desktop website, but we're thinking about adding it. Is this a feature you would use? In this case, it's super direct. It's not even like saying, oh, we're developing this or something like that. No, they're just asking, do you want this feature? And that's the most direct customer feedback you can get. And they just measured who would click yes, who would click no, and then decide if they were going to give any resources to the development of this functionality. It is important to take a few things into account. You have to ensure that the painted door produces real feedback, so actually getting it from real customers, not from some dev environment where only internal users are. You have to make sure that there is that not everyone is all the time in this test, because if you're running this all the time, then people at some point get like really disappointed. You should not have 10 buttons on your homepage that all ask you, oh, we're developing this feature, do you want to have it? Because people are going to get really frustrated. So you have to be really careful of when you apply it, where you apply it, and to how many people. So maybe you don't want to show it to everyone, but you just want to get a reasonable amount of people to answer your questionnaire, so you show it maybe to 5% of your traffic. And in that way, you figure out what is the next feature that we should be developing. In this way, you also get a lot of influence as developer yourself on which features you actually can develop. Let's say there's a feature that you would really like to make because you're interested in it and you think it's something your customers need. Instead of having to convince a lot of business people, you have the power to run a test and say, look, I have the data, this many of our customers want it, can I now develop this cool application that I was thinking about? And that gives you a lot of insights in what you can do. So, experiments help answer what to build and when to build it. You can challenge yourself and your team to test before building a feature and to test during the design of it. A winning variation is not always a valuable experiment, like we saw with the beard experiment, like putting beards on everything is not gonna always help you. And testing during prioritization maximizes test value because it really helps you move around what things I should be developing, which things I should not be developing. Now let's say we decided we're gonna build this new feature. Then of course, we want to mitigate risk during launch. We don't want anything to break, we don't want things to go wrong, we don't want users complaining, we don't want any of that stuff. We just want people to go to our application and be happy to use it and give good feedback on your new feature, right? That's what we all dream of. Usually that's not how launches of new features go, but let's try. So how are we changing this? So this is another experiment on our own website, actually on our marketing website. So we had this thing, it was a free trial. Yeah, makes sense. People want to try something, you should have that. And at some point our marketing team or our sales team, I don't know who it was, decided we're not going to do free trials anymore. So we removed it from the website. So we didn't have this feature anymore. And then people started complaining, mostly on Twitter, hey, we can't have a free trial anymore, when you're going to put it back on your website. And we're like, okay, maybe we should be doing something with it. But the way it was before wasn't good. We don't have that feature anymore. So we have to develop a feature in a way that we can test how the feature should actually look like. And we did that with what we call a feature flag. So it's a software development technique that lets you turn certain functionality on or off, and also make it easy, without redeploying code, to change a feature slightly. So you can say a certain name should be changing, there should be some parameters that you can adjust just in the UI without actually going back into your code and doing a code deployment. And it allows for better control of experimentation, and it's also really used in risk mitigation, because let's say you launch a new feature to a feature flag, then it's easily, let's say, it goes completely wrong, like your users don't like it at all, then with one click of a button, without doing a redeployment of code, you're capable of stopping that being active, so your users don't see it anymore. So it's really easy to mitigate risk in this way. So we run a feature test in which we run different variations of that feature flag. And one thing we tried was the experiment, what should be the length of the free trial? 30 days versus 14 days. So we developed the feature, which is the new free trial, because we used to have it before, and now we have a new version of it. That's just a piece of code, somewhere in our code base, right? And with our tool, we can then say the variable key trial length should be either 30 days or 14 days. And then we're gonna launch this, and 1/3 of our customers is gonna see that there's no free trial, and some people are gonna be able to get a 14-day free trial, and some people are going to be able to get a 30-day free trial. Unfortunately, I don't have the results of this experiment yet, because as you saw in the previous slide, it started end of September. The longest experiment is 30 days minimum, and then we still need to get feedback, so we don't have the results of this yet. A customer story of using this functionality is about a major department store, and they're looking into reducing their third-party vendors. And they decide maybe our recommendations engine, so that thing on an e-commerce website that says other users also like this, or these products are almost sold out. Like that algorithm, they had that from a third-party vendor. But they were thinking, I want to reduce this, and I'm going to develop it in-house. And they wanted to see if they could develop that in a way that it was cheaper and better, and also better for their customers. So they ran a server-side experiment to test their own algorithm versus the algorithm of the vendor. And in that way, tried to see if they could save cost on their third-party vendor. Another way you could be running experiments is with a non-negative experiment. So we're talking a lot about getting significant uplifts and getting winners and improving the software, but sometimes you just have to release code. And there's not necessarily an increase expected in anything, but the most important thing you're trying to achieve is that it at least does not affect any of your main goals that you have with your application. In that way, you make sure that it does not impact your business. So a story about this is a major department store was struggling with their website, and they weren't selling too much online. Now they were thinking, how can we use this website in another way? Now you can make money with websites in one other way, and that's putting ads on it. Putting ads on a website is by most users not really liked, because it just looks ugly and like you're, oh, I'm looking at all these ads. So they wanted to put ads on their website, but not in a way that it would impact their already quite low selling online. So they tested putting ads on their website up to the point that people were not too annoyed by it, but they would still gather some income from ads. So that's one way of doing this kind of non-negative experiments. And then you ran your experiments with different variations, and you want to know how I'm going to roll this out. So the first thing you can do is a stage rollout. You want to mitigate risk. You only roll it out first to 10%. You gradually roll it out, like every day 10% more. You see if there's no complaints or Twitter or anything, or you measure it with any other metric, and then everyone has the new feature. That is something Instagram uses a lot. Then there's some people that have the new feature that messages their friend, oh, I have this new thing, and then they don't have it. People get disappointed sometimes as well. So if it's really cool, you have to roll it out fast, but that's something you can manage. Something else I already mentioned, Facebook likes New Zealand, so they do a targeted rollout. They just launch it in one area of the world, and other people are not capable of using it yet. Then you get less of the effect of friends having a feature already and you don't. Then there is a dark launch. It means a major feature is ready. You validate the feature by giving whitelisted access to, for example, only internal people in your company. And then by removing that whitelist, usually can do that without deploying code, you release it to everyone. You can also make it a beta or exclusive access. So you select certain customers and say, hey, you can be in our beta. It's a really cool new feature. Normally you'd have to pay for it, but you can get it for free, but we need your feedback, and it's still in beta. So that's one way of also getting customer feedback. Then we can also look into Canary Releases, which is something also Rage Sang talked about in his talk. It's a way of releasing to mitigate the risk and send it only to a small percentage of traffic. And it helps you discover if there is any issue with performance or load balancing or things like that. And the last thing you can do is do it via a kill switch. And a kill switch means that you can immediately turn it on or off. And the issue with all these gradual rollouts, that it's sometimes quite hard to measure the impact of it. You want that a new feature has a certain impact, but if you really gradually roll it out, the effect kind of fades out because people are gradually introduced to it. So if you want to really do a big launch, then you can do that, but make sure there's a kill switch behind it, because if the feature is not what people expect of it, you can immediately turn it off and go back as if nothing ever happened. So that's one way that you, without code deploy, are capable of turning off a feature. So what we need to know is that you need to identify the core questions associated with a new feature. You need to turn these questions into testable variables during development. Every launch should include in an experiment. And you have to validate your assumptions with data. so you're not developing the wrong thing. Now, we already decided what we're developing by testing it on real customers. We now test different variations. We launched our app via rollout. And then what? Well, it doesn't stop there, because experiments can also help you either promote the new feature, or it can help you improve the new feature. So innovate and iterate and actually make it even better. One way we did this, we used to only make tools for front-end development, but then we launched our SDKs to do server-side experimentation. And we made one pop-up like this, and another way where we promoted this is by when people were creating a new experiment, we would tell them, here's the possibility of also creating a server-side experiment. Something else we worked on is performance. So you might be thinking, hey, I'm looking at a blank screen. Yeah, that's true. So when you're loading our app, you first see the spinner. You never want to see the spinner, right? You just want your website loads fast, and we also want that because our customers using this website, they need to see what they are doing. So we tested different ways of loading what's on this page. Normally, this page would load all experiments someone is running at the moment and has been running in the past. Now, we tested two different algorithms. One that's only showing experiments that are currently active, and one that's showing experiments that are currently active plus the ones that are just being paused. And we looked if there was a significant difference. And then we found that when you load only the experiments that are active at the moment, which is obviously a lot less than everything also created in the past, gave a significant improvement on the load time of that page. Plus, we probably also measured if it didn't have a negative impact on customer feedback, but on first load, when you first open that page, it would only load the active ones, and therefore significantly improve the load time, which is good for our performance. A last thing we did to promote the results is that when people wanted to see experiment results in our UI, the button was here. Look for it. It's in the top right corner. This wasn't the best button ever created by us, and also as a result, people were like, where are my results? Like, I can't find them. I don't blame them either. So we created a new little button, which is here, which is together with all the other buttons you use the rest of the time. So it makes a lot more sense to have a button together with all the other functionalities that you're capable of doing. And we measured how many people were viewing the results page, actually checking their statistical significant results. And we saw by adding the button in a location where people would actually see it, we increased the click-through rate to our results page by 28%. It's like a really big uplift. And it was also 99% statistical significant. So now we actually have that button there. Normally, it's not an experiment anymore. We rolled it out, and all users are using now the correct button. So conclusion of this part. Experimenting isn't over when a feature launches. After that, you should still be iterating. You can do lightweight promotions to get meaningful insights in how people want to use your new feature. And you can revisit launches to challenge conclusions and improve on iterating. So it doesn't mean that experimentation stops when the experiment itself has been finished. So, and this is another overview of how you could be doing experiment-driven development. So in every stage of the software development lifecycle, you can be running experiments. When you're gathering requirements, you can run a painted door test to get information about what your users want. In the design phase, you can do user studies to get feedback on the design. In the implementation phase, you can run internal or simulated experiments to validate the technical design. When you're, well, of course you do QA, that shouldn't require too much experimenting. I think QA should always be a steady process. And then when you launch, you can do that with a phased rollout, with a new feature promotion campaign. There's all kinds of things you could be doing in that phase. And then, of course, the most important thing, iteration. And that's what most companies are actually doing right now. They just iterate on new features. And there's very few companies in this world that actually implement experimentation in their total development lifecycle. So today we learned experimentation, what is experimentation, and why you should be doing it, because we know complex variations have more chance of winning. You as developers should be doing experimentation. We saw how software development has changed and why we should be doing experiment-driven software development, because we don't know what our users want, and we want to be data-driven and use that. And then we saw how you could implement this in every part of your software development lifecycle. During every phase of software development, you can be using experimentation. And to leave you all with an inspiring quote from Booking.com, they actually put every single launch in an experiment. There's nothing new on the Booking.com website that is not an experiment. And I hope that everyone learned something today about how to do experimentation in your software development lifecycle. And if there's any questions, let me know. Thank you. Questions? Yeah.
You are always measuring. What kind of tools you are using? Because I like the idea of doing it, but measuring will be the hardest part.
Yeah. So the question is, how are we going to measure this? So our company has tools in our SDKs for measuring it, but another way of doing it is using standard analytics tools like Adobe Analytics or Google Analytics or any of the other tools that are for analytics. And we also normally integrate with those to do that kind of analysis. So that's one way of measuring it. And another thing we do, like let's say we're measuring performance, then we use a tool like Honeycomb to measure like from data to measure what's the time to first contentful paint or whatever. Like any tool that you can imagine, you can measure anything with. Other questions? Yeah?
How do you measure over time? Like your experiment, at a certain point you validate it as successful.
Mm-hmm.
But if it's increasing a lot, it could decrease after that.
Yeah, so
how do you do that?
So the question is, how do you deal with changes over time? And like at some point you have to say the experiment is done, right? When is it done? So our statistical model is developed in a way that it's not like a regular t-test. Because if everyone remembers like university statistics, like for a t-test, like when you're comparing two or more things, you always have to say, I'm expecting this impact, and therefore I calculate that I should be running this test like with this many samples. And then you can calculate how much time that should take. But our model is made in a way that it's not necessary to do that. So it's once you get statistical significance in our model, it's not going down anymore. It knows sure that there is a statistical significant difference, and then you can basically pause it and then actually deploy the winning variation. So that's the idea. Another question.
See other influences like demographic or in time, for example, if you say, do I want to sell bathing suits or wool jackets or so, and then you do it in the winter or in the summer, you get different results?
Yeah, so you're asking how do, for example, weather influences, do I want to sell bathing suits or scarves? How does that influence, like, or geography, or things might be popular in one area or not in another? So that goes more into another topic, which we call personalization. And there is a way of also identifying where someone is or what weather is it in a person's location, and then personalize a website based on that information. So that would be one way of doing it.
I mean the other way around.
Okay.
If it's something you don't think of that could be of influence, that changes the outcome of your experiment.
Yeah, so that could. Yeah, so we are capable of detecting those changes. So let's say you don't know what the influence is, right? But let's say you get inconclusive results, and you expected that it would be a major uplift. What you can then do is look into the results and actually filter the results, for example, by geography. You can filter the results by weather. You can filter the results by what device people are using. And in that way, you get insight, maybe this was only relevant to people who are using a mobile phone and live in the US. and in that way you analyze your results on a deeper level than just overall.
Yeah, but then still you could miss that kind of influence, which might.
I mean, of course, there's always a possibility that you miss something, right? That's, yeah, that's of course something that can happen. Yeah.
What would be best practice if you combine multiple experiments on a website, for example? Because then they can influence each other if you change the color of the button and maybe also the picture or something like that.
Yeah. So the question is, how do you handle that multiple experiments don't influence each other, or they might actually influence each other? What happens? How do you then analyze the results? So there's one possibility, and is that you put experiments in a mutual exclusive group. And that means if you're seeing the button change color experiment, you will never be able to see the image change experiment because they might influence each other. The only downside to that is that you really, if you want to run a lot of experiments at the same time and you all want to make them mutual exclusive, that you're really reducing the amount of traffic that you have, and that then the chance of getting results becomes a lot smaller. So there's always a balance on when you should be doing that and when not. I know, for example, at Booking.com, they never do it. They say, yeah, that's going to happen. We accept that, and we just run all experiments at the same time, and you can be in 100 experiments at the same time. And they said, okay, we just care about the amount of traffic, and we don't care about experiments being mutual exclusive. I have other customers that really do want things to be mutual exclusive, so they use it. But they never put like more than 4 things in the same group, so to remain the traffic. See another question here? So how big a user group should be for an experiment to be effective? So it really depends on what kind of change you're expecting. The bigger the change, the smaller the group is you need to measure a difference. So yeah, you can make some kind of estimate. In general, most of our customers have websites with a traffic of at least 100,000 visitors a month, most actually bigger. But you can also get results with smaller groups. Then you just have to wait longer. If you have 100,000 visitors a day, then you usually get results within a few hours. If you have 100,000 visitors a month, you might have to wait 3 weeks to get results. So depends a bit on the situation. Other questions? No? Then thanks everyone for your attention. If you do want to know more, we are doing a meetup in our office in Amsterdam on November 20th on a Tuesday. So if you're interested, you can, you're welcome in our office and sign up on the website here. And also, please rate my talk in the JFall app. And thanks a lot, everyone.